This is the homework assignment page 508, section 7.4 of the math analysis. Whitney in class today said that if I channeled my inner gangsta a little, that she would definitely watch this. So here we go. All right, he's about to get crazy here with this trigonometry. You ready? All right, here we go. All right, that's about it for the gangster. All right, back to regular talking. So, Whitney, I hope you are listening. Okay, let's start with number 20 from the homework. The directions on these just said state the amplitude, period, phase shift, and vertical shift. So again, I've got four things. Amp, period, phase shift, and vertical shift. I can extract all those directly from the equation. Remember from class, the easy things are the amp and the vertical shift. Amplitude is just the number that's multiplied, which in this case would be a number 1 right there. Realize that, again, this is written backwards. That's fine. It doesn't matter. It's just the -4 would usually be over here, but it's no real difference. So the amplitude is 1. Remember, it's not -1 because amplitude is a distance, so it's always positive. So amp is 1, easy enough. -4, again, it could be over here, and that'd be fine. So -4 is a vertical shift of, you can either say down 4, or you could just say -4, either way. So those two are easy to deal with. Now we'll get to the little bit tougher stuff. Remember we talked about in class, all the rules that we have are assuming that you have factored whatever you got to factor away from the t value. So in this case, it's really a 1/3. That's a 1. That's a terrible one. We'll try that again. There we go. It's a 1/3 that we're factoring out of this. So I'm not going to rewrite everything. I'm just going to rewrite this part. This would be 1/3 t plus, now we have to think to ourselves, 1/3 times something right in here is going to have to equal pi over 4. And again, if it's difficult at first to figure out what it is, I would actually write this out as an equation. 1/3 times something, that's the green here, equals pi over 4. Pi over 4. Well, how would we solve this? Well, we'd simply times by 3. So now we've got x equals that. So 3 pi over 4 is what goes in here. Now we have it factored. Now that we have it factored, the phase shift is simply this number. But remember, since it's plus, this actually means move to the left 3 pi over 4. So for phase shift, you can either say left 3 pi over 4, or the book may say, and sometimes it's written just -3 pi over 4. But since we're talking phase shift, we should know that that means left or right movement. So -3 pi over 4. Last thing is the period. This goes back to our previous section of notes. That's not the period. You take the normal period of sine, which is 2 pi, and you divide by that number. Again, that would of course mean multiplied by the reciprocal, 2 pi times 3 over 1, 6 pi. Didn't have to graph anything, so this one is done. There's all our stuff. Again, the key is factoring that 1/3 out of the fraction. Next one I want to do is number 30. It says write a sine function with the given amplitude, period, phase shift, and vertical shift, respectively. So, just so we've got it sorted out here. There's our amp. There's our period. There's our phase shift. There's our vertical shift. And they put 1s and -1s to try to make it look confusing, but it's not actually terribly difficult. Let's break it down by pieces. Okay, so it said it wants a sine function. The amp of 1 It's real nice because we would write a 1 in front. We don't even really have to write it though, so we're going to pretty much just ignore that. Again, the other easy thing to deal with is the vertical shift. -1, that means on the end of the machine, somewhere out here, there's going to be a -1. Again, fairly easy to deal with. When it's broken down like this, the phase shift is actually pretty easy to deal with. -1 for a phase shift means that I'm going to have, let's switch colors here again. I'm going to have T plus 1, because again, if the phase shift is -1, that means in the formula it's +1. Oh, I should have closed that with a black parenthesis. That's perfect. Not very good. Okay. And now remember the period 1. Oh, no, wait. That doesn't mean a 1 goes in here. That means I have to think for the period. That means that 2 pi divided by something. I'll call it the, let's go with happy face. 2 pi divided by something has to equal a period of 1. Well, 2 pi divided by what is 1? That would be 2 pi. 2 pi divided by 2 pi equals 1. So that's what goes in here, 2 pi. That's a pi symbol, another bad pi symbol. So there is the machine that will result in those. And again, I'm fine with you leaving it like this. You may see, we got arrows here. You may see them multiply it in, drop it in like it's hot, and drop it in like it's hot. So what you may see it written as sine, and then parenthesis, 2 pi t plus 2 pi. Close the parenthesis, -1. All I did was, again, multiply that in. So you may see that. I'm fine with that answer. Okay, next one, number 36, a little bit tougher. It gives us the graph, and we have to write both a sine and a cosine function that articulates what's going on in this graph. I'm actually going to start with the cosine function, because actually this one's made a little easier for cosine. Remember, cosines typically look, let's do this in the corner here. A normal cosine looks like a U shape. You have that right here. So the reason the cosine is a little easier is because it's starting up top like a normal cosine does. So if we think, okay, what are the attributes of this as a cosine function? What is its amp? What is its period? What is its phase shift? And what is its vertical shift? Take care of the two easy ones first. Amp. It's 3.5 up, 3.5 down, so there's your amp, 3.5. What's the vertical shift? It's nothing at all, because it's centered right in the middle. There's no up or down. You're evenly distributed here. So there is none, 0 or none. Okay, what is the period of the function? Well, you can either think of it from right there to right there. How far is that? But we mentioned this in class. It really doesn't matter where you decide to pick to look at it for the period. The period's the same no matter what window you decide to look at. So what I mean is, instead of looking at it, and this is going to be terribly drawn, but instead of, that's a window. Instead of looking at that window and going, well, wait, I'm not quite sure what that is. We'll figure it out anyway later, but, oh, I don't know what that is. Okay, no big deal. Why not look at it instead? Oh, that's not good looking at all. Within this window, basically from here to here, because the period is the same however you look at it. How far is it from pi over 3 to pi? There we go. From pi over 3 to pi is a distance of 2 pi over 3. So right here the period is 2 pi over 3. And you might have already sorted that out. If this is pi over 3 and this is pi, right in the middle here, that has to be 2 pi over 3, because 1/3, 2/3, 2/3. I'm sorry, 3/3. So if you look at it from this valley to this valley, the length is 2 pi over 3. Or if you look at it from this peak to this peak, the length of that is 2 pi over 3. It doesn't matter how you look at it. So either way, period, 2 pi over 3. The last thing to look at is the phase shift, and since I decided I'm going to take this cosine to actually start here, this is my starting point for the cosine. It says cosine start. I don't have a phase shift because it's starting right on the vertical axis. So now I'm ready to actually write my equation. So according to the cosine one, there is no phase shift. So it's a cosine machine. Amplitude's 3.5. 3.5 in front. I don't have to put a negative out because it is starting up like cosine usually does. There is no phase shift. Oh, excuse me, I don't even need a parenthesis then. Get rid of that. So since there is no phase shift, I don't have to put like t plus anything or t minus anything. There's no vertical shift, so I don't need to put anything back here like +1 or +7 or -2, whatever. All I have to do is figure out what number will go in to give me a period of 2 pi over 3. Remember, that's not the number that goes in. I take the normal period of cosine, 2 pi, divided by something has to equal 2 pi over 3. Don't overthink this. Just take a step back and look at this. 2 pi over something, 2 pi over 3. The number has to be 3. So that's what goes in there, 3t. Now that's not the only way to write an accurate cosine machine. Don't worry about writing multiple ones, but I just want to show you what else you could do. I could have said, oh, the cosine is starting right here instead, this green start, instead of that blue start. If I had picked that as my cosine start, let me move that over. If I had picked that right there as my cosine start, then, well, let's think what this would look like, what the equation would look like. Well, it'd be a negative 3.5 because it's starting below. The period is still the same, so that's not going to influence this number. Cosine of 3. But now there's a phase shift. If I'm starting here, that's starting right pi over 3. So that means my equation would be minus pi over 3. So either one's fine. This obviously is a little simpler, but there are actually infinitely many ways to write the cosine machine. Okay, so there's the cosine. Now we're going to do the sine. We'll go with, I used up a lot of good colors. Let's go with the light blue. Oh, no, that's just a green, never mind. So let's go with the purple over here. Okay, so for the sine machine, most of the stuff is completely carried over, is directly carried over. So the amp is still 3.5, whether it's a sine or cosine. The period, we mentioned this in class, it doesn't matter what frame of reference you look at it. The period of the sine version or the cosine version is always the same. And further articulate this, between those two, that would be a full sine machine. If I move that over that far, and I move that over that far, it'll be the exact same length as that cosine machine. So essentially what I'm getting at is the periods are the same. So the period is still 2 pi over 3. Well, I like this new color. The phase shift, now, I marked some places where I could say this is the beginning of it. I could say that's the beginning of the sine, because sine starts on. I could say that's the beginning of the sine. I could say that's the beginning of the sine. It doesn't really matter. I'm just going to pick the first one. It doesn't really matter, though. Let me erase some of all this other stuff here. Hopefully you got that. If not, rewind. Okay. So if I'm picking that as my starting point, now I need to figure out where that is because it's not clearly identified. Well, every increment here, if you imagine this cosine wave, that cosine wave that we had, again, we knew that it ended at 2 pi over 3. We figured that out earlier. This is 1 pi over 3. These then, therefore, are being split in half as well. So if you took pi over 3 and split it in half, pi over 3 and split it in half, that means divide by 2 or multiply by a half. That means that this must be at pi over 6, which makes sense. 1/6, 2/6, 3/6, 4/6, which is 2/3, 5/6, 6 over 6, which is pi. So it makes sense. So now every little increment, I could even add this one, every single increment is 1/6 more. Okay, so since I decided this is my sine start right here, then that means it's a phase shift to the right of pi over 6. So pi over 6 or positive pi over 6 or so, however you want to illustrate that. Again, still no vertical shift. So everything was exactly the same as what was the cosine, except the phase shift changes. These are still the same. So now for a sine machine, I can go 3.5 sine, I'll leave that space there, t minus pi over 6, that's my phase shift, pi over 6. And now, again, since it's the same period, I already did the calculation down here to figure out what number would go in the machine. It was a 3, same number, 3 will go in there. And that makes sense because 2 pi divided by 3, hey, 2 pi divided by 3, that's your period. Again, this is not the only right answer to this. This is not the only right answer. There are actually infinitely many for, oh, sorry, one thing. Since I decided to make that my starting point, it was going down first. There should be a negative on that. That isn't my only starting point, though. Maybe you decided you want to pick this one as your start. So, again, just to illustrate that there are multiple ways to do this, if I pick that to be my starting point, then, okay, amp's still the same. This time it would be positive, because if I pick that as my start, then it goes up like it should. The period still doesn't change, so that 3 number still goes right here. That's a sign written really bad. The only thing that would change is my phase shift. It's just I picked a different starting point. And again, we said these are each a 6, so 1/6, 2/6, 3/6. 3 over 6 is pi over 2. You can just say minus pi over 2. It's the exact same machine, though, so either one would be acceptable. 2 more problems I want to work on. Number 45. These ones, it actually just says to sketch at least one cycle of the function. So we'll be as lazy as we can and only do one cycle. No point in doing any more than one. Okay, so again, good idea to just list out everything that's happening. Amp, period, phase shift, vertical shift. The only things that this doesn't really account for is reflections. There's a negative that you need to be aware of. Okay, amp, number in front, 3. Easy enough. Vertical shift, nada. There's no plus or minus over here, so none. That'll make it easier. Remember, to figure out the phase shift correctly, you have to factor this number out. So this would be 2 times t plus something. Remember, that means that 2 times something has to equal pi over 2. And again, if you're having trouble with that, just think, okay, 2 times something has to equal pi over 2. If I multiply by a half, you're left with that something is pi over 4. Pi, 2 times 2 is 4. Again, what that does is easily extracts out the phase shift. So your phase shift is just to the left, pi over 4. Or you might see it written minus pi over 4. Normal period of sine, normal period is 2 pi divided by 2. 2 pi divided by 2 pi. That's your period. Okay, now I have all the pertinent information. Now I can set up a graph. And again, make your graph not just automatically perfectly evenly split. Since I'm just graphing one cycle, see, I drew that really straight line. And I know I'm starting negative pi over 4. I should definitely include a little bit of the negative side. But again, I'm going to extend it out to the right because that's just the easiest way to do it. Okay, so let's account for everything. We've got amp of 3, but with no vertical shift. So that just means go 1, 2, 3, 1, 2, 3. I know it's going to peak and valley at those. Phase shift is negative pi over 4, so I'll just call that negative pi over 4. Now, from that starting point, the full cycle is going to take pi, but it's starting at negative pi over 4. And again, what that means is from here, a distance, it's supposed to be a bracket, a distance of pi. So you can just say, oh, I'd take negative pi over 4 plus pi. And you might be able to do this in your head, but negative pi over 4 plus pi. That would be 4 pi over 4. So 3 pi over 4 is where it ends. So the far end over here is going to be 3 pi over 4. Let's see if I can get rid of that pi thing that I added in there. And just move this away. Perfect. Okay. Now we have to evenly space it. We always take our period and divide by 4. I'll go with that. You always take your period and divide by 4 to get your increments. So every increment is just pi over 4. So you start at the far left, add pi over 4, and you're at 0. That's going to be another increment. Add another, oops, add another pi over 4. You'd be at 1 pi over 4. Add another pi over 4. You'd be at 2 pi over 4, or pi over 2. And just as a check, add another, again, that was 2/4, plus 1/4. Hey, 3/4. Perfect. So there's our 4 even increments. 1, 2, 3, 4. Perfect. Now we're finally ready to graph this. There was no negatives out here. It's a sine function. Sines always start on. So on. No negatives, so next increment above. On. Below. On. And, oh, not going to quite make it good enough. There is one cycle of that sine wave. Okay, last problem. One more of these. Just says graph it. So again, always a good idea to list everything that's happening. Amp, period, phase shift, vertical shift. Okay. Amplitude, 5. Easy enough. Vertical shift, yep. +2 or up 2. You can say up 2 or +2, either way. What's nice about this one is there's really nothing to factor out. It's a 1 in front of this. Well, how do you factor out a 1? Well, everything has a 1 in it, so that's not a big deal. So we really don't actually have anything to factor out. There's nothing in front of this t value. So that is our phase shift right there. Negative pi over 3 would mean actually go to the right pi over 3, or plus pi over 3, or something like that. Go to the right pi over 3. And the period, remember, you usually divide by whatever's there, but hey, there's nothing there, so you just take the normal period of cosine, 2 pi. Okay, now I'm ready to set up my graph. Again, look at what you actually have going on. We have up to, and it's going to be amped up. So this thing's going to be more on the positive wise, so more on the top than the bottom. And it's really not going to have any negative because I'm starting to the right and I'm going to graph to the right. So let's go maybe right about there. Okay, now since we do have this vertical shift, I usually start there. That means we're starting at 2. That's our new middle line. This is actually tougher to do than you may think to draw this dotted line. Okay, that's supposed to be a straight dotted line. That's okay. Now the amplitude from there is 5, so go up 5 from there. 1, 2, 3, 4, 5. So we're actually up at 7. Go down 5. 1, 2, 3, 4, 5. That's negative 3. Okay, so it's going to be contained within this span. We've got a phase shift of pi over 3, so it's actually going to start at pi over 3. Now you got to be careful here. Oh, hey, the period's 2 pi. So we're used to saying, oh, so at the far end would be 2 pi. Careful, remember, it's add 2 pi onto the starting point. So it'd be pi over 3, add 2 pi. So that would be like adding 6 over 3. See how I got that to fill in nicely there? So that means this is going to end at 7 pi over 3. Pi over 3 plus 6 pi over 3. So it'll end at 7 pi over 3. We know it's going to split in half and then in half, so we've got to get our 4 even increments. You always take the period and split it into 4 even increments. We already know this, though. The normal period of 2 pi splits into, that's a pi symbol, pi over 2 increments. That says increments. Okay. So from here, pi over 2, pi over 2, pi over 2, pi over 2. But again, it's not just the number pi over 2. I have to add it onto this. So you've got to think, yeah, we'll just do this up here. If I had pi over 3 plus pi over 2. Okay, common denominators would be 6, so that'd be 2 pi over 6 plus 3 pi over 6. So my next increment is, that would be 5 pi over 6. Nope, that's written in black. Oh well, we'll keep going with it. The next increment would be if I took that, 5 pi over 6, and I added another half pi. Again, I'm adding half pi onto the 5 pi over 6. I'm adding half a pi onto the 5 pi over 6. So that'd be 3, 6, 7, 8. 8 pi over 6. That reduces to 4 pi over 3. To get to the next increment, add another 3 pi over 6. Again, that's adding a half pi, onto the previous spot, which was those ones. So 3, 6, 9, 10, 11 pi over 6. It's 11. And so then the last one, just as a check, adding another half pi. 3, 6, 9, 12, 14 pi over 6. 14 over 6 is 7 over 3. So perfect. We set it all up. Final thing now is just to do our graph. It is a, we'll go back to that good purple. It's a cosine. So cosine usually starts above. There's no negative out in front. So we're good there. So we start above. Next increment on, but again, this is my on, that dotted line. Then next increment below. Then on. Then above. And we get that nice cosine UE shape, maybe. Oh, missed it. Oh my, that is a terrible cosine, but you know what it is. We'll just make that bigger so it hits it. Perfect. And we'll just shade that in more so it looks like it's nice and straight. Alright. Okay, that made it worse, but that's okay. Alright, so that's 5 of the 11 problems from this. Hopefully that helps. Again, if Whitney's watching, I hope she is, because I gave you the little gangster theme. So hope you players are feeling better, and we got ourselves a test next week. Peace.